Okay, so this is the last video that I'm going to do in this particular set. I hope that I have more uploaded and ready to go before before actually you even reach this particular video. But this is part of an experimental process, and just trying to see a little bit about what's going on and how to use this software. But we're just diving right in. We're going into the next set of problems. The idea is still the same. Uh, you're giving you're given a particular polynomial, and so now you're going to graph that that polynomial. Does this match the criteria that we have stated before? Does this make sense? This is 2x to the fourth, which means it's an even degree polynomial, and the leading coefficient is positive, so that means it's going to start off towards towards positive infinity, and it's going to finish towards positive infinity, which we have both of those characteristics here. If we were to, change the x and y values of our graph, we would see that that does indeed happen. And so as I just kind of change how the graph looks a little bit. I don't want to zoom too far out because I do want to see what happens to the intercept, but those characteristics are still the same. And I see these different, it's a degree 4, which means we have at most 4 real roots, and I see them here. But one thing that I notice as I'm looking through these, I see negative 2.5. That's negative 5 halves. And I see the positive 3. So those are going to be kind of my starting points. But then I also see a pairing. I see plus or minus 1.732. And so that tells me that there's something else going on here. I'm going to work with the positive 3 first, and then the negative 2.5. So I'm going to write those down. So here's 3, and x is negative 2.5, and I want to work with the positive 3 very first. So here's 3, and this is 2x to no, this is synthetic division. I don't have to write x to the fourth. That's a minus 1 in front of the x cubed, minus 21, 3, and 45. So. And then we just start the synthetic division process. 2 times 3 is 6, minus 1 is 5, times 3 is 15, and negative 21 plus 15 is a negative 6, and times 3 is negative 18, so that's negative 15, times 3 is a negative 45, and 0. If I start moving through this too fast, you can always pause the video, go back and then check your work in the calculator as well. So now I have this new graph. Now this time, and you're more than welcome to graph this if you wish, but we have this 2x cubed plus 5x squared minus 6x minus 15, and if x equals 3 is a root, that means x minus 3 is a factor. But I just want to continue on because I'm trying to get to that other number. We saw this negative 2, this negative 2.5. And the question is, does it match? Is this a possibility in that rational zero theorem? And so I look at the coefficients I look at the factors of negative 15, which is, and again, this is plus or minus, but that's 1, 3, 5, and 15. And then the factors of 2, which is 1 and 2. And can I get 5 halves or negative 2.5, which I can right there. There's my 5 halves, and then there's my negative. So I know that that's a valid possibility. So I'm going to continue this synthetic division. Negative 2.5, again, that is negative 5 halves. So I put the negative 5 halves. I put the negative 5 halves here in the box. I'm going to bring down the 2, and then just start, just start this process. The 2 divided by 2 is 1 times negative 5 is negative 5. The 5 minus 5 is 0. Negative 5 halves times 0 is 0. That's a negative 6. And then negative 6 divided by 2 is a negative 3. Times negative 5 is a positive 15. And so then there's my remainder. And this 2x minus 6 is not the correct answer because I have to divide by 2. And so when I do, I get 1, 0, negative 3, which is x squared minus 3. Now at this point, I do want to graph to see a little bit about what's going on. And so I'm going to take a look. I know what one of the roots, one of the factors are. It's x minus 3. From the x equals negative 5 halves, I get 2x is equal to negative 5. So 2x plus 5 equals 0. And so those are my other factors. So what I should have up to this point is x plus 3. No, x minus 3. Yeah. Sorry about that. I have to always, I got to go back and check. So this is x minus 3 times 2x plus 5. And then x squared minus 3. So that's the graph that I want to verify. X minus 3, 2x plus 5, and x squared, was it minus 3? Okay, those match up, and so now I'm looking at this last piece. And what I have is a quadratic, and I see that negative positive. Whenever I see this negative positive, two things come to mind, either irrationals or imaginary. And in this case, since it's a real solution, it can't be imaginary, which means that we're looking at an irrational number pairing. It means that I need to take this x squared minus 3 and have to solve it algebraically. And so I set that equal to 0. Now I could use the quadratic formula, and I have to recognize that my b value is 0. Or I can solve this one a little bit more carefully. If I add 3 to both sides, I get that x squared is 3. And so then when I take the square root, I get x is equal to plus or minus square root of 3. And that's where those other two factors come from. So if I expand this one completely, then I get x plus square root of 3 and x minus square root of 3. So now I want to check it. I'm going to go back up here. X minus SQRT, 3, and x plus SQRT, 3. And there's my original, there's my new graph, and so this one is completely factored. The very last thing that I have to do is put this in the proper order. So what I have is the factor that's associated with negative 2.5. That needs to go first. Then my positive square root of 3 needs to go next. Negative, and then finally the negative 3. So when I rewrite this, my final answer is 2x plus 5, x plus square root of 3, x minus square root of 3, and x minus 3. And so then that would be my final answer. It just so happens that those two numbers are side by side That's not always going to be the case. For example, if I had a root 1, now this is not your answer, so I'm not going to circle it. But if you had a root 1, it would go in between, and so on.